Hi, in this lecture we are going to focus on the a priori algorithm. The objective of the lecture, we want to look at what the a priori algorithm is. We want to look at the assumptions of the a priori algorithm, the steps for the a priori algorithm. Then we are going to take a numeric example of the a priori algorithm, where we are going to look in depth on the support, confidence, and the lift matrix. So our lecture is going to be in two parts. The first part is going to be theoretical, and then we are going to do the practical working of the a priori algorithm. When you come to think of the a priori algorithm, this is an association rule algorithm. Its main aim and objective is to come up with interesting relationships which are strong. The term a priori can be referred to as prior knowledge. For you to have a deep understanding of the a priori algorithm, I would encourage you to watch my previous recording on the association rules. The a priori algorithm was given by Agrawa and Scrat in 1994. It makes use of the frequent item sets to generate association rules. With the help of these association rules, it determines how strong or how weak two objects are related. The a priori algorithm is an iterative process of finding the frequent item sets from a large data set. What do we mean when we are talking about frequent item sets? Basically, we are talking about item sets whose support is greater than the minimum or equal to the user-defined minimum support. The a priori algorithm works on some assumptions. It assumes that all subsets of a frequent item set must be frequent. This is the a priori property. We are going to look at that as we take on a numeric example. If an item set is infrequent, all its subsets will be infrequent. That is, if A and B are all frequent item sets together, then individually A and B should also be frequent item sets. To understand the a priori algorithm, we have to understand the related terms such as the support. And in a summary, support of X and Y is equal to the frequency of X and Y together divided by total transactions. The other term we have to understand is the confidence. The confidence of X and Y is support of X and Y divided by support of X, or divided by the antecedent. The other term we have to understand is the lift. The lift of X and Y is calculated by the support of X and Y divided by the support of X multiplied by the support of Y, or the confidence of X and Y divided by the consequent which is y. A deep explanation of the metrics are given in my previous lecture on association rules. Now, let's take a look at the steps of the a priori algorithm. In summary, you would want to identify unique items in a database or in a transactional database. And then you also want to identify the minimum support and the minimum confidence defined. In the next step, you then want to calculate the frequent occurrence of each item discovered in step 1. Then we compare each item support count against the minimum support given or defined. We eliminate all item sets which do not meet the minimum required support count. And step number 3, you then want to generate a next item set using the results in step number 2. We then repeat step number 2 and step number 3 until we have reached a position where we are left with only one item set, or when the next item set's results gives us a 0 item set, which means the minimum required. In that case, where you have reached a 0 item set, you then want to go a step back and take the previous item sets. Those are what are the values on the items that we're going to consider for step number 4. In step number 4, we then want to generate association rules. When we have got the association rules, we want to calculate their confidence. And then we compare their results with the minimum confidence defined. We then also eliminate all rules which do not meet the minimum confidence. When we have eliminated this and we are left with those that meet the minimum confidence, we then are not yet we do not consider that we have reached a position where we consider the rules. So we then apply a third metric, which is the lift, to lift the confidence up. Then we'll sort the results in decreasing order. Now let's take an example. This is where we are now going to do a numeric example calculation. Given our data set of transactions and the total number of transactions are 9, and those are the item sets in our data set, transactional data sets, with a minimum support of 2 and a minimum confidence of 50%. Let's work and see how the a priori algorithm works. Our first step is then to identify unique items that are found in this whole dataset. So let's create our first item set table. We are also going to look at the percentage or the decimal position of the support. So let's identify unique items that are in our data set. We have got A, we have got B, C, D, and E. So once we have identified the items in our data set, we then want to count the support. So we go and count how many times or how frequent does item A appear in the whole transaction of the database. So we go and count 1, 2, 3, 4, 5, and 6. We write down the 6. We also go ahead and do that for B, C, D, and E. If you are going to count for the number of items where B appears in the whole data set, we are going to get a value of 7. We do them the same for item number 6, item C, 1, 2, 3, 4, 5, and 6. So we get a 6. We do the same for D, and we have got 1 and 2, so we write down 2. We do the same for E, and it appears only on transaction number 8, and we write a 1. Then, for us to get a support count in decimal position, we then want to say 6 divided by the number of transactions that we have in our data set, which is 9, and we get 0.667. You can then multiply it by 100 to get a percentage. I will leave it as it is. And then we also go ahead and do the same for B divided by 9. We do the same for C, 6 divided by 9. We also go ahead and do the same for D, which is equals to 2 divided by 9. We do the same for the last item set, 1 divided by 9. Let's keep that values for now. Our next step is then to compare the support values by the minimum support given. Let's take that down a little bit. Then if we're going to compare with the minimum support given, we see that E does not satisfy the minimum support given. So we eliminate item set E, since it's no longer a frequent item set. Once we have found the result, we then continue to do a next generation of the next item sets, which is a 2 item set. So this is where we said the process is iterative. So we continue to then let's try to come up with a combination of the next item values. We pick out our first item, which is A. Then we pick the second item, which is B. We go ahead and pick A and C. We go ahead and pick A and D. We go ahead. Now E has been eliminated from this result, so we stop with the A. Then we go on to take a B. Consider a B combination with a C. Since B and A has already been included on the list, we can include a B and a D. We also include a C and a D. This creates our next item set table. Let me just increase the font so that it becomes clear. Now, once we have done that, we then also go ahead and check how many times or how frequent does A and B appear together in our original dataset. So if we're going to go and count, we find AB1, AB2, AB3, AB4. So our count is 4. A and C, how many times does the A and C appear in our dataset? We find AC1, AC2, AC3, AC4. So we count 4. We go and do the same for AD. A and D appear 1 and we get a 1. We do the same for B and C, back to our original, and we found B and C1, B and C2, B and C3, B and C4. So we write a 4. We go and do the same for BD, BD1, BD2, and we put a 2. We go and check for C and D, C and D, and we get a 0. We then go ahead and do the calculations of the support in a decimal point, where we have got 4 divided by 9. We do the same for the other values. 1 divided by 9, 4 divided by 9, 2 divided by 9, and that we get also a 0. Let's take these items so that we can compare them with the minimum support. If we then compare the result that we have found with the minimum support, we will see that CD does not meet the minimum required support. Also, AD do not meet the minimum required support. So we are left with those AB, AC, BC, and BD as the item sets that meet the minimum required. This takes us again to a third item set. We take A and B and we try to create a third item set. So if we're taking this first one, we go to the one that is below, and A is already included and C is an option, so we put a C. We do the same, A, B, and A and B are already included and C has already been included, so we go for a B, D, where B is already included but we have a D. So we have got A, B, and D as a combination. We proceed to check if there is another combination that we can have. And we have done the AB. Let's try an AC combination. A, C, and then we check for the third item. A, C, and if you go for B, it's already included, and then a C is already included, a B is already included, but a D is an option. So we have got an A, C, and D. Could there be another option that we have to, let's try a B, C. B, C, B, C, and B and a D we include. Now, these are the third item set or three item set that we have managed to create. Let's go ahead and see how frequent they appear in the dataset. A, B, C appear together. A, B, C, A, B, C, we have two. What about A, B, D? A, B, D, and this is the only time where we have three item sets which have got those values. So it appears one. For a quick selection, you do not want to consider two item sets since we are now looking at three item sets. So you will want to look at a transaction where there is a minimum of three item sets and above. So let's consider ACD. The first one is not there. ACD, ACD, this gives us a 0. BCD, we also look at B, E, B, C, D, and we also get a 0. Let's take this and also check with the minimum support. If we look, the minimum support of 2, it means to say all these are going to be eliminated and we remain with 1. Also, whilst we are here, let me take you back to the a priori property, which says if C, D are not frequent, then also its subsets are not frequent. Meaning to say, if we reach out to this position where we have a combination of a C, D, it means to say that item set already has been eliminated and we could have just eliminated it without even trying to count and waste time. A and D, if we go where there is an A and a D, also it means it's not frequent. So we could have just eliminated it without even including it on this table. That's another advantage of the a priori, where it uses its assumptions. Now that we have reached this position, our next step is then to try and create the rules out of these frequent item sets. There is no more need for us to do another fourth item set, since even if you look there, we have got 3 item sets. And also, it means that the fourth one will automatically eliminate the one that we have, and we end up with 0 item sets, which will then force us to go a step back to the last iteration and then be forced to pick the same result. So now what we want to do is to then come up with the rules. So to create the rules, we are going to use another sheet. And our item sets result were A, B, and C. These are the item sets that we are going to consider. So we try to look at all possible rules or combination. So that we can calculate the confidence. What about if we say A and B drive C? A and C drive B. We can also consider a B and C to drive A. We can also consider an A to drive both B and C. We can also consider a B to drive both A and C. We can also consider C to drive both A and B. Could they be another possible rule? C, a combination of A and B, combination of B, A and C, and B and C. Let's work with those rules. You will find out that the association rules can create as many rules as possible. But our main objective is to find interesting relationships which are strong. And taking from the last result, our support is 2, which takes us to give all of these to have a support of 2. To calculate the confidence, using the formula that we have already displayed, confidence can be calculated as the support, let's say support of A or the items B and C divided by the antecedent or the left support of the antecedent in our case is that, which gives us a value of, let's just leave that for now and let's make this more visible. Okay, so what is the support of A, B, and C. It is 2. 2 divided by the support of A and B together. So we go back to our results where A and B appear together. And then we take the count because we have already calculated that, which is 4. So let's put a 4. This gives us a result of 0.5, which is equal to 50%. We do the same for A, C, and B. And you will see that our answer there still remains. Let's just take that from the top and bring it down. And then this time it is A and C. We then go on to take 2, which is our support from this. And then we look for the support of C from our previous table where we have A and C being another 4. So this gives us a 4 and the result is a 0.5, which again gives us a result of 50%. We do the same again, and this time our antecedent is B and C. We already have our support divided by, we go and check the support of B and C from the previous. B and C again is a 4. So we put a 4 and our result is 0.5, which again gives us 50%. With the same, again we do, but this time our support is A. So let's go ahead and do a 2 divided by the support of 2. We go and check the support of 2 from the first frequent item sets, which becomes 6, which is 6. And then we divide by 6. This should give us a value of 0.333 to give us a 33.3%. We do the same for the next item set or the row, and this gives us a result of 2 divided by, we go and check for B, and B is a 7 from this one item set. So we get a 7, and then this gives us a result of 0.28571, which gives us a percentage of something close to 29. We do calculate again for the last, and where the left value is C, to give us the left value is a C, to give us a 2 divided by, we go and check again the support of C, which is 6 from here. So divided by 6, which is a value that we have already calculated on top. So it gives us a 33.3%. After we have calculated these values, We then want also again to consider only those that meet the minimum requirement confidence, and the minimum required confidence is equals to 50% coming from our first given data set. So this means to say all these ones do not meet the minimum required. If we're going to look at the results of the confidence, we would then say that where A and B appear together, they derive product C with a 50%. However, this could be misleading, because sometimes the items which seem to appear together, it's not because they have got a strong relationship, but maybe because they are frequently bought, and then they will look like they appear together. We then want to implement the third metric, which is the lift. So to implement the lift on the results, however, this time when we implement the lift, we then want to make all possible combinations of the rows, since these are all frequent item sets, which now generate more rows that we need to lift. So we are going to then put the rows. I would also want to put their support, the lift, and then let me just say lift 1 and then say lift 2. I will explain more why I have got 2 lifts. In my formula, I have given 2 methods. So let's see how the results will appear. So when we are calculating, we want to calculate the lifts. This time we are going to expand the rows. Let's start with the rows that we already have, where we have got A and B driving C, and the other one that we have is A and C driving a B. The other one that we have is a B driving C, B and C driving A. These are the results that we have from the previous calculations, and their support I would prefer again to put another column where again I say support 2, where we have got support 1. The first support is just a frequency which is 2, 2, 2. Then the second support, I would want to put it in a decimal, where we have got 2 divided by the number of transactions, which is n, and it gives us a 0.222 divided by 9, 0, 2 divided by 9. Now with these results, we then want to use our formula to calculate, and our first formula says to calculate the lift, we have to say support of x and y divided by the support of x, the product of support of x and support of y. So we are going to do the calculation of that value. This gives us a value of support of x and y. Let's go and check the support of x and y. In our example there, we have got the support of A, B, and C, which in turn is this value. So let's put a 0.22 divided by the support of the product of A, B, and C. So let's multiply the support of A. What is the support of A? Let's go to the previous and get the value of support of A, which happened to be 0.667, and the support of B, it's a 0.778. The support of C, it's the same as of A. So let's take those values and then calculate, which gives us a 0.67 multiplied by a 0.78 multiplied by a 0.67. This gives us a value of let's just work that out and see how the value of 0.22 divided by the product of 0.67 multiplied by 0.78 multiplied by 0.6867, sorry, and then this gives us a value of 0.628. 0.628 as the value. The second option that we have also highlighted is where we then say confidence is calculated by saying confidence of A, B, C, let's take confidence of X and Y divided by the support of the right, which is Y. This is the second formula that we're going to use. Let's see what result it gives us. So we are looking at the confidence of A, B, C, which happens to be this value that we have calculated. And it gives us a 0.5 divided by the confidence, the support of Y, which we then go also to get, which is in our case there is support of C becomes the consequent, which is the right side. So let's go and check for 0.67, which is this value. So we bring a 0.67. This gives us a value of, let's put that in our calculator, 0.5 divided by 0.67, we get a value of 0.74. 0.74, which is slightly different from the one that we have found in this other method. We proceed. If we're going to do the sum calculation again for AC driving out B, we are going to see that using this same formula where we have the support of XY, it means to say the support of ACB still remains the same, which gives us a value of 0.22 divided by, again, the same value of multiplying the product of X and Y, because it's the same that we have used there. So really it doesn't not change, and therefore our answer there will remain the same for all these combination, which gives us a 0.628. Again, we get a 0.628. And let's take a look at the use of the confidence divided by the support. The confidence, again, that we get from AC driving B is still 50%. So let's put 0.5 divided. However, it is the consequent that has changed. And if we go for the consequent of B, of the value of B, we get a 0.778, which changes the value of our lift to give us a value of 0.5 divided by 0.78, 0.64. 0.64. Again, the value is slightly different, however, this time is closer. So when we are going to be using this confidence, our value differs from the lift using the support, which I would prefer to use because at some point it uses gives us a better degree. However, when we are going to do some interpretation of the lift, the result might still remain the same, but I prefer to use the second option of confidence divided by support of the right side or the consequent. We can also continue to do combinations such as A drive B, A drive C. Since all these are frequent item sets, and if sub-frequent item sets are frequent, that means to say even the previous item set also must be frequent. So we can also go ahead and create more possible rules from the ones that are frequent, and then we proceed to do some calculations where we can also say B on itself drives A, and B drives C. We can also go and do a C drives A, and just to remove this formula there. Okay, no fill, right? We can also proceed to do a C. Okay, we need automatic C drives C driving A and C driving a B. Okay, this is a font of 12 so that we have same thing font. Let's see what happens with A driving B. What is the support of A and B? Let's take it from the previous. Support of 2A and B is 4, which is also a 0.444. Right, which is 4, and then this has got a 0.444. If we are going to do the calculation using the support divided by the support, the product of the support, what are we going to get? We are going to get a 0.44 divided by, let's go ahead and get the product of support of X, and so let's go and check the support of A and B from the previous. The support of A and B is 0.67 and 0.78. So let's bring those down here, and we say 0.68 multiplied by 0.78. This gives us a value of, let's see what we get. Let's take our calculator. 0.44 divided by the product of 0.68 multiplied by 0.78. This gives us a value of a 0.83. So let's take that value there. Right. Let's do the calculation using the confidence where we have this value. Right. The next thing that we would then want to do is to then calculate the confidence of A and B. And we know the formula of calculating the confidence of A and B is that we take the support divided by the antecedent. So to do that, first of all, we need to calculate the confidence, where we are going to do a 0.44 as the confidence, as the support, and then we divide that by the answer of support of the left side. So the left becomes an A. So let's go and look at the support of A, which is 0.67. So we're going to divide by 67 to get the confidence, which then, if we are going to do the calculation, 0.44 divided by 0.67, we get a 0.65. 67, which is a 0.67. Then that's the confidence, and then for us to calculate the lift, we have to then divide that by the right side, which is B, and then we want to go and get the support of B, which happens to be 0.78. So we bring a 0.78, which gives us a value of, let's go and put that in our calculator, 0.67 divided by 0.78 gives us a value of 0.85. Again, if we are going to check the value there, which becomes 0.86, Again, if we're going to look at the value, they are very close to each other. However, if you are going to check, there's more precision when you're losing the second lift of the value. This is why I prefer the second lift. So you can go ahead and do the computations of the other values. When we consider, then we need to consider the results of all the calculations that we have. What now we need to evaluate the lift is that when we have a lift, when our lift is equal to 1 or closer to 1. What does that mean? When we have a lift where it's equal to 1 or closer to 1, it means to say that the items that we are considering are independent to each other. So we cannot come up with a rule which then says they are going to appear together. When we have a lift that is greater than 1, this is the interesting lift that we would want to consider. A value where it's greater than 1 of the lift, it means to say that these items are dependent to each other. One items can improve the sales of the other. However, when you are considering the lift, this is not a causation. It's not a hard and fixed result that then definitely it will happen. We are only putting rules which we can use to make a better decision. The other lift result is a lift which is smaller than 1. When we have a lift that is smaller than 1 and the result is not closer to 1 or near to 1, what it means is that these products are most likely to be substitutes of the other. That means to say a purchase of one product might lead to a negative effect, which is they are more of a competitors. This is how the a priori algorithm works. This brings to the end of this lecture. Before we come to the end, if you are new to this channel, I would then encourage you to click the subscribe button below so that you won't miss future updates on algorithms. Also, like the video if you have enjoyed this lecture. Thank you.